Hi, my name is Mark Schvetz, and I'm a developer at Chariot Solutions. Now, we are in for a real treat. I heard about this talk a while ago, and now I'm finally going to see it. We love type systems for code, so why not have a type system for design? Sounds interesting, right? So here to tell us more about that are my colleagues, Matt Gilbride and Drew DeCarme.
All right. Thank you, Mark. I don't even think I need to introduce myself. I'll just go off of that. All right. So can you see my screen?
Yep,
Yes.
We got slide deck.
All right, cool. So just for quick introductions, I think Mark did a pretty good job of it, but my name is Drew DeCarme. I'm a consultant at Chariot Solutions. And I've been doing front-end development for about roughly 10 years. And it's all kinds of front-end development. I've spent a lot of time, on the client side of the API, doing design work, doing, low-line front-end development, component design, component development. But it kind of like varies the entire gamut. But I was actually just recently converted to TypeScript by, again, my good colleague, Matt. And I'm proud to say that before yesterday, it was like 150 days since I last used JavaScript, but I have to reset the accident clock because I just used it this morning. So, and then I'll just give it to Matt.
Yeah, so my name is Matt Gilbride. I'm also a consultant at Chariot. I've been building various things with software for about the same number of years, different platforms. I guess kind of importantly, I was a back-end developer for most of my career, came to front-end, maybe 2 or 3 years ago. And I don't think I'm naturally very good at design. I need a guy like Drew with a good knack or like a designer to keep me from putting buttons in the wrong places, so to speak. But I'm passionate about maintainable code wherever it might lie, and I'm getting it better at design, little by little with Drew's help. So let's get started here. So Chariot obviously is our employer putting on this talk. Been in business for almost 2 decades now. 17 years ago, Drew and I were probably running around on a college campus somewhere doing God knows what. Actually, I don't even want to think about what I was doing 17 years ago. So let's move on. Let's get started.
All right. So what we're here to talk about is design systems, right? So probably, since it's the ETE, we're going to talk a little bit more of the technical parts. So creation, technical composition, maintenance, who does it, who are the responsibilities, component libraries, design, everyone's really familiar with this kind of stuff. But what we're actually really here to talk about is scalability, and not just scalability in the sense of, scaling horizontally, but we're talking, how to really future-proof your design implementation. And the scale that we're focused on doesn't necessarily come from like a bug report or a QA tester. So call these the non-technical forces of evil. So we're talking things like company rebrands. We're talking things like, a massive shift in creative leadership. Let's say a new engineering leader gets on, they don't like how half the code base is implemented. A quick hiring scheme where your entire like development core goes from 2 to 30 hands touching a specific part of your application. So there's so many different things that can happen on, like I said, the client side of the API, and there's so many non-technical factors that can really affect your design implementation, which can quickly unravel it. So what we're really here to talk about is scalability in the context of design and how we use technical solutions to actually fix some of those problems. So like I just said, we're talking about scalable design systems, right? So when Matt and I started this whole thing, we went full 8th grade on you, and we made this hypothesis. So I'm going to read it real quick just for the sake of argument. Try to follow along with me. But the first sentence is the most important one. So what we said is a design system can be broken down into parts that have very similar parallels to language primitives. So these commonalities allow us to take a more architectural approach to building our design systems. So we can use things like TypeScript and programmatic CSS generation through CSS and JS. And that would allow us to reach CSS nirvana. That's going to be a theme in this presentation. So what you can roughly say is that a design system is, roughly equivalent to a type system. So what we really mean to say is we're talking about type-safe design systems. So our main goal, and our goal throughout this is pretty simple. The first one being the most important part, is we want to create simple mechanisms in which to interface a lot of our design primitives. And keep that in the back of your head because we're going to explain that a little bit later. Some of the other ones are a little bit more intangible, and you can focus on them, but they're really, really important to the goal of this. So we want to increase the consistency of our style implementation. It's really, really important to make sure we have consistency across. Steve just talked about that in his last implementation or his last presentation. We want to catch errors as early as possible. So not at runtime, not at build time, but we want to catch them as soon as you type that character into your IDE. We want to accommodate a lot of those shifting requirements and priorities. And if there's anything that happens outside of the technical organization, we want to make sure that we can accommodate those with, relative ease. And the last thing we want to do, and this is again very important for our argument, is that we want to make this as easy as possible to use. We want clear APIs. We want anyone across the stack, whether you're a designer or you're an engineer or a database admin or someone who just came on, we want you to be very clear and easy as possible to use. So when you leave here, we hope that you have a couple of things in mind. Number one, we hope that you can clearly articulate a design system. I think it's kind of like a nebulous concept, especially in the engineering world. It's like, yeah, it's components, not really. The next thing we want you to do is we never want you to use vanilla JS again, right? You want to go down to your local ink shop, throw 100 on the table and just get it tattooed, your TS config tattooed on your arm. That's how important it is. And then the third thing is that we really want you to understand that styling isn't an afterthought anymore. It's 2020, we have the iPad. It's an architecture decision. There's a lot of things that go into styling, and it needs to be considered the same way as a database architecture, as well as platform architecture as well. And the last thing is, obviously, after COVID, go give your designers a hug. They do a lot of work on the back end to make their design system as atomic as possible. And then what we need to do is understand some of what they're doing to make our job a little bit easier. All right, so here's a quick outline. We're going to talk about a quick history lesson. Obviously, we weren't there, but Matt's going to go through that. We're going to go through our design system 101 course. It's to be a very quick introduction on what they are. 3, we're going to give you pretty much the reason why you're listening to this, so while we're rambling on. The next thing, we're going to talk about atomic design system fission. Yeah, I know that's heavy. And then we're going to go through a couple demos and then just talk about what's next. So with that, I'm going to give it to Matt. We're going to pass this back and forth.
So quick history of the web from one of the dudes who was not there in the early 90s when people were, building up the web. I think I was like 5 or 6. But just to provide some context, again, this talk is about design systems specifically on the web. So we're going to be talking about HTML, CSS, and of course, JavaScript. So if you hate those 3 things, you might be in for a bad time. But unfortunately, hopefully WebAssembly is going to take over the world soon. I'm one of the people that's fully on board if it does. But until then, we're talking about building stuff in 2020, and that also means single page applications and SPA frameworks, right? So if you are one of the people who, is a little bit, you've got some misgivings about whether or not SPAs are good ideas, I might be with you. But since we're talking about trying to build production ready web apps in 2020, we're going to be talking about this thing from the scope of, building it with React, Angular, Vue, or whatever, Aurelia, whatever other framework you like. So going back to the history of the web, just want to remind everyone that, browsers were built to be forgiving, right? Back in the day, the whole point was that you can write CSS that's incorrect and the browser's just going to ignore it. You can even write, HTML in some cases that's incorrect and the browser's just going to render, its best guess at what you intended. And Drew and I don't disagree with that as a quality of browsers, right? We want browsers to be that way. The internet's supposed to be free and open for everyone. It should be easy for somebody to throw some markup and some CSS into a couple files and serve up their ideas for everybody else to consume. We live in the Twitter sphere, so that's the world we live in, and it's pretty good. It's a pretty decent world, my humble opinion. But when we're building enterprise scale apps, we usually don't want our mistakes to just be ignored, right? When we write incorrect CSS, when we write incorrect HTML, we want to know as soon as possible, and that kind of let that be the backdrop to this talk as we continue. So with that, I'm going to have Mark release our first poll as we run interference to try and switch who's sharing. So I'm going to stop sharing.
This is the first presentation where I had a poll.
All right, we got a poll. Sweet.
All right.
Everyone loves our polls. They say the greatest thing about our polls.
All right.
All right, I see your screen, Drew.
Cool. So while the poll's going on, I'm going to continue working. So we're going to talk briefly about what design systems are. Just as a quick disclaimer, I'm not actually a designer by profession, but I've done enough designing, and I have done, design of interfaces and things of that nature where I think I'd have enough credibility to kind of talk about this. So on the left-hand side, if you're really into jargon and you like, very lofty definitions that don't mean too much, you can read that. But what we're going to work off of is the definition on your right-hand side. So a design system, just broken down to one sentence, is it's a group of always changing deliverables used across a company that coach teams into creating consistent experiences. So no matter where you are in the organization, if you're trying to create a product, there should be a set of collective deliverables that you can refer to that will help you do your job better to make sure that those products that you are creating align across the organization. So it's very, very simple. So there's a couple of parts of the design system. And again, this is kind of opinionated. I'm trying to boil this down a little bit to make it a little bit more coherent to our argument. But I'm just going to kind of walk through them. So on the left-hand side, you have the actual parts of the design system. On the right-hand side are just some quick descriptions. So the first and probably the most important thing is you really need to define your target of use. So who's going to be using your design system? Is it marketing? Is it engineering? And who's going to be using it and then why? Why are they using it? Are they using it to develop print? Are they using it to develop marketing materials? Is it more of a digital agency where you actually have to go in and create digital products over and over again? So knowing who your target is really kind of helps shape the next section, which is just coming up with your shared goals. So a design system has to have a purpose. It needs a sort of guiding light or a North Star where everyone gets on the same page. So once you have people rowing in the same direction, then things are a little bit more fluid. The next thing is called design principles, and it's probably the most ambiguous portion of a design system, but how they're set is they're just guiding sentences that shape how a specific problem is approached, right? So if you think about it, and we were to make a design principle for our slides here, or just ETE in general, or any technical conference, we could probably say a principle would be demos are a lot louder than slides, right? And it's actually what we're not doing right now. We're just talking at you behind these white backgrounds. But a design principle is something that you kind of stand by. It's like your mantra. You wake up in the morning, like, I'm going to have a great day. Demos are louder than slides. Like, I'm going to ease customer use, and I'm going to do that throughout my entire day and not my entire job. That's a quick example of a design principle. And a lot of organizations have a lot of varying design principles that they kind of stand by. The next one, or I guess the next two, is kind of what everyone's really familiar with. Brand identity, color, tone, typography, animation, anything that kind of makes your brand the brand, and then components and patterns. So, and these are pretty important to have respectively. So you can think of your components as Legos. I think everyone gets that, React, duh. And then obviously the patterns are their associated instructions. So just as a quick example, you're not going to buy the Millennium Falcon Lego kit and not use the instructions, right? Han's going to be pretty pissed that the Millennium Falcon doesn't work the right way. So having the components is good, but also having a set of instructions with them is even more important. And then lastly are just best practices. So as you go about implementing your design system and people are working with it, you want to kind of lay down the tracks and see where people walk first, and then lay the sidewalk down to see, hey, this actually worked really well, and it worked well with a customer. Let's make a best practice out of that. So all of these together pretty much formulate your organizational wide design system. But for the sake of argument in our talk, we're just going to narrow our scope down and talk about brand identity and components and patterns. So again, some of the others are more important. You'll see them surface in some of the examples that we say, but for right now, we're just going to talk about brand identity and patterns and components. So these are just technical goals that I've experienced throughout my career in implementing design systems that I think hold pretty true to make sure that you can execute a good technical design system throughout your entire org. The first one, and Steve in his presentation mentioned it, is consistent language. It's so important that people in different organizations or different parts of your organization are calling things the same thing. That can come down to colors. It can come down to even like orders. If someone says that this is a meal and another one says that this is a menu, it doesn't really jive, even though they might be the same thing. So establishing a consistent language from the design side all the way down to the DB is super important. Next.
So if you don't mind me interrupting you, Drew, this is where I like to say, for you back-end guys, if you're using domain-driven design, things like that, and you've read about those principles, they should not stop at UI UX, right? Like domain-driven design should carry all the way through to the design system. So I'll leave it at that. Sorry, Drew.
Yeah, no, it's exactly right. The next set, creating a standard set of components for reuse. That's so self-explanatory, but it's central to a design system. We want to create a system that anyone can use, right? We talked a little bit about the barrier to entry and how a lot of existing implementations right now are just kind of tough to get started with. implementing a design system at a technical level, you really want to make sure that you think about the API that you're creating and then who's going to be using it. The next four kind of speak to, or number 4 and number 5 kind of speak to number 3, but we want to prevent as much human error as possible through our best practices. We can implement best practices through technical implementation. And then again, like easing the developer experience, right? You don't want to create something that's cumbersome. It's going to like make people angry as they code. Happy code means happy products. And then lastly, I think is another very important thing is not everything's going to fit into your nice box. Not everything's going to be, aligned the same way. You're going to have different outstanding requirements, and you want to build a system that has escape hatches or different methods where you can allow for that customization. So you want to lock it down as much as you possibly can, but you have to be pragmatic in it because you need to understand that there are going to be certain situations where you're going to have to deviate from your existing pattern to accommodate the needs of the product. So hang on to those. We're going to come back to them in a little bit. But Mark, second poll.
Okay, so to kind of set the stage here, so it is early summer 2019, and Drew and I converge on a client site where we need to implement a design system. So context here, we were building, had the opportunity to build a greenfield React app, and then it was backed by a pretty simple API layer, REST over Node with a Postgres database backend. This client had already done one kind of throwaway MVP. So the second time around, the thing needed to be production ready for go live, once we were all done. And the other important point is kind of the engagement was limited in time and budget, right? So we needed to establish some best practices, get this thing ready to go, and then give them something that was going to outlive our tenure. And, something that they were going to be able to grow and refactor and change as their own requirements evolve. The other thing that's important is that we're talking about a team at that time of less than 5 engineers. I think it was actually like 3 when we started, and it was 5 when we finished. And all these guys are experienced and very capable, but none of them are like front-end JavaScript engineers by trade. I think for almost all of them, it was kind of like their first go around with an SPA. So, Node, React, and TypeScript was kind of an obvious choice given the rest of their stack, and I'm not going to get into that. But we wanted to, we thought about how we could make styling easier for these guys as well. And that's where Drew joined the team and was influential in bringing styled components, which is a CSS and JS library, to the floor. And we found that adding that to the rest of the stack really made things really nice. So the point is that, again, we wanted something to live past our tenure, something that was going to be relatively easy for non-JS people to adopt, and something that's going to surface implementation errors, including styling implementation errors, as early as possible. So in this journey with this client, we discovered kind of the benefits of a combination of technologies. They went live earlier this year, I think January or February, and a lot of these ideas are all in that code base. Now, not all of the ideas are in their code base. If you guys are listening, specifically things like make style, make color, some of the functions aren't in there. They all these ideas kind of came out of what we thought was good about that implementation. So we've got that line at the bottom, our implementation needed to be easy to use and maintainable, and everybody says that. So what does that mean when we're talking about styling a web app, right? So it means kind of the same thing when we're talking about anything else. We wanted to kind of set the stage for this talk by putting the solutions on some sort of 2D graph that looked fancy, right? So on one axis of the graph, we wanted to kind of have ease of use. How easy is this thing? How easy is it to make something that looks reasonably good in a short amount of time? Onboard developers, how good is the documentation, and how simple is the API? Opposed against that, we have maintainability. So how easy is it to handle a full rebrand? How easy is it to handle drastically changing requirements, things like that? So that sets the stage for this slide, where we kind of are going to oppose different approaches to styling web apps on the kind of easy to maintain, easy to use spectrum. So top left, we've got, okay, this thing is super scalable to something that's going to get super big, but maybe a little bit difficult for somebody to pick up from the beginning. And then bottom right, we've got you just drop your components in there and it looks reasonably good. So if you think the solutions are going to be pretty obvious, you might be right. And this next slide is definitely going to cause some disagreement amongst people that know the landscape here, but let's just go to town. So probably makes sense to put vanilla CSS at the origin here, right? And there's lots of people that will argue that you should just use vanilla CSS, HTML, and JS, and like build a really simple app and deploy that out, and like that's going to satisfy your requirements. Totally valid point in a lot of cases. But if you're building a big enterprise scale web app, you're probably not doing that. So the first step that you probably take is like CSS preprocessors that have been around since, at least since I even started building web apps, right? They are kind of the first step above CSS, but you can't just like, you still need to write a bunch of CSS with a preprocessor in order to build yourself an app that looks professional. Opposed to that's your component libraries, right? All of us can take semantic UI or material UI or element UI and like give it a configuration file that tells us what colors we want, and then just start putting buttons everywhere. And it like looks decent. And what I found from personal experience though is that when you end up with a designer who wants things to look a specific way and things get bigger, you find yourself actually fighting against that component library as much as it's helping you, and wondering whether or not you would have been better off if you'd written some of your own low-level components. After that, in the middle here, we have kind of like CSS libraries. They were around even before the component libraries, where you get a bunch of classes, you just use those classes in your markup, and they make things look good. One interesting idea that's kind of newer is utility first CSS libraries like Tailwind CSS. That jives a little bit with what Drew and I kind of like from an approach standpoint, but it's not quite where we're going. So finally, we've got CSS and JS, and that's like a little bit of a hot button issue, right? Like, why are we now writing JavaScript that generates CSS too? Like, have we not had enough of like languages generating other languages when we're building web apps yet? And the thing I like about CSS and JS is that, and we'll get into this in a second, you're probably building your app with a JavaScript framework anyway. You're already writing 90% of that app in JavaScript. So you might as well, if you're gonna add an extra language, why add a CSS preprocessor when you can just use JavaScript directly? And then finally, where Drew and I realized we were like trying to approach Nirvana is you add TypeScript to this equation and things get really cool. And it's not just TypeScript, it's kind of an approach with these things all combined, but we're gonna get into that in a second. So with that said, I've got kind of two level setting bullets here just to kind of like make some points for anyone who's kind of skeptical about these technologies. So first, this is Chris Coyer, who is he's a contributor on CSS tricks and kind of a well-known authority on things related to CSS. And this article is written, I think, like 6 months ago. You guys can pull it up and read it. But in this article, he says, I think it's worth taking a look at CSS and JS ideas if you're working in a component-heavy JavaScript framework anyway. You are already co-locating templates, functionality, and data queries. I think Vue earns notoriety for the whole concept of a single file component, template, styles, and business logic all in one file. Sound familiar? And then he cites someone else that says, you know, this is a good idea, especially if you're part of a team where everyone understands basic JavaScript, which in 2020, whether you like it or not, is kind of the lowest common denominator amongst your front-end engineers, right? Everybody's got to know JavaScript. They can have varying levels of proficiency in CSS and HTML, but JavaScript is the one thing that everyone's got to use. So I would argue that, you know, if you're opposed to CSS and JS, think about these points and maybe give it a try. And then the second kind of level setting slide is about type systems. So Richard Feldman gave a great talk yesterday about kind of programming paradigms, and these topics kind of overlap. And the point of this slide, though, is that we are not here in this particular talk to do the dynamic versus static type checking battle. Someone else from Chariot, maybe even Mark, could argue with us about this and probably win. But that's just kind of, it's not the point of this talk, so we're going to move on from it quickly. But before we move on from it, I'd like to make the point that TypeScript is a gradual type system, and that is an important distinction, right? Type checking is optional in TypeScript. Just because you're using TypeScript doesn't mean you have to type check all the things. You can ignore things. You can still run your code if it doesn't pass the type checker, which is not the case with, like, say, Java. Like, if you're coming from a server side, like strongly typed language with a compiler, like that's not always the case. So have less fear about using it in your front end. Second point, it attempts to provide syntax that is as close to plain JavaScript as possible, which is where it might depart from things like CoffeeScript and other solutions that we've seen that transpile to JavaScript, right? you can read TypeScript if you're a JS engineer with zero learning curve. You can just look at it, it's going to make sense. It's just adding static type checking to a language that's dynamically typed under the hood. There's other solutions that do this, and you can read about kind of Python type hints and other languages that pull this off, and it's honestly pretty cool. It's kind of the best of both worlds, right? You get the type checking when you want it, you ignore the type checking when you don't want it, and like maybe you're a happy camper if you try it out. So with that being said, just want to go back, before I pass it back to Drew, to our original hypothesis, right? So the idea is that it's not just about using TypeScript and using like styled components, some sort of CSS and JS framework. It's about leveraging those two things together to construct an API, right? A low-level design system API, whereby people use well-defined, well-thought-out functions to produce their CSS, right? It's not just like I just drop hex color here and then I use it, or I use a CSS variable. It's using these things to build an API for your design system, just like you build an API for everything else. So with that, welcome to CSS Nirvana. I'm going to pass it up on to Drew.
It's interesting to note that the What is the Internet? Keanu Reeves movie got 22% of the votes. I like our audience.
All those movies are on Netflix now, by the way, side note. I rewatched the original the other day.
All right, cool. So we have our last poll up there. Go ahead and answer it. But I'm going to ask you real quick to go full Mel Gibson again. Let's put on our tinfoil hats. And we're going to talk about a subatomic design system theory. So this is something that both Matt and I came up with, and we're going to kind of highlight it. And this is the beef of the talk. So if you zoned out for the past, 20, 30 minutes, welcome back. My name is Matt. My name is Drew. That's Matt. All right, so here's our mental model for how we architected this system. So hopefully everyone's seen this before. I mean, this is the point in the conference where I'd say, everyone raise your hand if you've heard of Brad Frost's atomic design model. I'm going to assume that everyone has, or actually I'm going to assume that 10% has, and we'll just continue from there.
Maybe we should have used a poll for this.
Take our
yeah, whatever. Okay. Yeah.
But all component systems right now are based on this model, right? You have your atoms, which are your lowest level components, buttons, inputs, things of that nature. You have your molecules, which take those atoms and kind of put them together. Think of tabs. Organisms are one step higher. Templates are things that can be reused, and pages are sort of what you interact with and have all those elements on the screen, right? So that is component design, like de facto, like we can't argue that. That's what everything is based on right now. But if you think about it, design systems are also done the same way. So if you look at things like Sketch or Figma or Framer, the way that these things are, or the way that these design tools are actually designed is that you build out these atoms yourself. So you have to build out the style of an input. You have to build out the style of a button. And then from there, you can use those. Sketch calls them symbols. I'm not sure what Figma calls it. But you can use those symbols to make more symbols and then more symbols. So the entire flow of a component of component design is also modeled in these modern Sketch or these modern design tools. So Framer is actually taking even one step further, and now you can actually export your components in React. That's kind of the out of the scope of the conversation, but you can see how closely these tools against our sort of component model in our heads align. So we're going to do what no one did, and we're going to split the atom and control it. So we're going to call this atomic design fission. So when we looked at the context of design, actually no one calls CERN about this. I don't want to get any calls. But when we looked at the context of design, we realized and we proposed that our atoms, our inputs, our buttons, and things of that nature can actually be comprised of various smaller bits, and we're going to call those particles. All of those different particles interact with each other to create one design atom. So I'm going to use a quick example. I'm pretty sure everyone's familiar with the material UI input, where the placeholder text becomes the label text once you focus into it. That's not just one atom. That is a combination of a lot of different styles and a lot of different things going on in the background to make that happen. We're going to talk about those in the sense of particles, right? All right. So let's dive a little bit deeper into what we're calling a particle. So a particle is a collection of types and utilities that when combined and used together, they create one full type-safe atom. So there's two types, or there's two kinds. There's types and utilities. The first one, which are probably the most important, are our types. So we have primitive types, and then we have composite types. So primitives are mutually exclusive types that don't overlap with each other, and combined with composite types, they pretty much make the DNA for our type system or our type-safe design system. We then use utilities to interface those design primitives in a safe way, and they can create values or actual well-formed CSS properties. All right, so let's talk about primitive types. They're the absolute lowest building block of your design system. Like I said before, mutually exclusive. They can't overlap with each other. You can't have a color of 16 pixels and a size of blue. It doesn't work that way. So we can assume that those are our lowest level blocks of our design system. So you can roughly equivalent those to integers, booleans, strings, things of that nature. And then font is its own thing on its own, right? It's something that operates exterior to anything. You can't have like a font of blue. You can have a font color of blue, but font in itself is the very lowest level part. So here's an example of some primitive types. And again, what we're going to show you isn't really, there's no wizard stuff behind here, right? We're not reinventing the wheel or anything like that. We're trying to break our design system down on a very elemental and simple problem. So our size has a semantic union type here, which goes from extra small all the way up to extra large, and that makes our size type. Boom, done. And then you can see with color, our color type is made up of a couple other unions. We have stateful colors, which be success warnings. We have application colors, light, grayscales, primary colors, secondary colors. We have fixed colors. Those could be darks or lights or anything else that your design system needs. You combine all of those unions together and you get your one design primitive type. All right, taking that one step further, we can actually have composite types. So composite types, they utilize one or many primitive types. So when you think about that, I'm going to use the typography example pretty heavily here, but a typography can roughly be equivalent to like an object or a dictionary, and that's comprised of size, color, and font. So font size, font color, the type of font, line height, anything that goes into the typography can be made up of a primitive type or another composite type. Spacing is another composite type, and that can be roughly equivalent to like a list or a map. And that's comprised of your size as it's related to other elements. So
yeah, and that one is kind of a weird analogy there, but I just wanted to make the point that we were thinking about how these things kind of are parallel with one another. And if you think about spacing, as something compared to like a list in a programming language, space doesn't make sense without the context of whatever other thing is next to it, whether that be the edge of the window or like the other div or button that something's next to. When you say something has padding left, that only makes sense in the context of whatever thing is to the left of it. Sorry, Drew, I interrupted you again.
No, it's a perfect point. So let's take a look at a composite type. And again, like I said, we're not using any generics here. This is just full type composition. So we have a font family type, which is a couple different font families that we want to use. We have a font style. Typically, it's like normal, italic, strong, underline. We have a font weight value, and that's just another union that goes up to 900. We have a font weight name, and I'll speak to this in a second, but that goes from thin all the way up to black. We have different font for different OSs. And then what that does is you can take all of those different types together, combine them with some primitives, and you can make what we're calling another composite type, but a property type. And that property type is the direct interface that your utility uses in order to interface these types. So what do I mean by that? If you build a utility to use or to make a type safe property, you're going to want that utility to interface your primitives.
Hey Drew, go to the next slide.
Oh,
there you go.
Yeah.
The power of having two speakers.
There you go. So what I'm talking about is a value utility. And that value utility, or any utility in general, is that it has to have an interface, right? You put something in and you get something out, right? But that interface is going to define what you actually bring in. So for make color, we're going to make a color composite property type. And that's just, all it's going to do is output a hexadecimal value. And then we have make size, and that takes in a size property composite type. And that can output a rem or an m or a pixel, depending upon whatever you have in your config. So here's a quick example of a value utility. And like I said before in the last slide, a value utility only outputs a specific value, like 16 pixels, blue, 1.5, something like that, right? But it's interesting to note that your utilities are kind of your space to make whatever the needs of your organization's design system fit within the design primitives that you have. So you can do whatever you want in here. There's no set way, there's no standard. This isn't a library or anything like that. This is more of a paradigm. But essentially what you're doing is you're defining your interface. and then you're doing some stuff after you get that value from your interface, and then you're outputting what you want in sort of an output that you normally agree upon. So if you look at the make color function, you can see that it takes a specific interface. And if you look a bit harder, you'll realize that it could probably be improved. So at the beginning of Typescript, I actually wrote this, and actually Matt's going to talk a little bit more about how to improve this, but more on that a little bit later. So the last part is your property utilities, and that extends the type of value utility. So a property utility is a utility that uses a composite type or a property type. They're interchangeable. And that outputs a well-formed CSS property. So you can think of this, instead of saying like, I want my padding to be 16 pixels, it actually outputs that entire string saying padding of 16 pixels. So if you look at make inset and make outset, they both take the same properties, you know, in margin and padding both have, you know, vertical, horizontal, top, left, bottom, right. So you take those in, you use those composite properties, and that outputs a specific string. Same thing with make font, right? I don't know how many times you actually use make font, and everyone does it just a little bit differently. If something changes, you can't scale it, but filtering it through this utility right here that interfaces your actual design primitives, the things that you define early on, really helps make a nice cohesive application that scales well too. And the last part is make responsive. I'll actually detail that in a second. So here's the make responsive utility. On the left-hand side, you have your responsive device types. Phone, medium, large, and then you have that mapped to a constant of the specific values that you have for that. So phone's 320, tablet portrait 768, you know, pretty standard stuff. But on the right-hand side, I think anyone who's written media queries before knows that they suck. You can never get.
I can't do it. I just used the function make responsive after Drew wrote it for me.
Yeah, it's a totally non-scalable thing. I mean, look at it, min width, max width, -1. It doesn't make any sense, right? And repeating that over and over again without a utility, actually without a type-safe utility, massive margin for error, especially as you get into responsive design. So what we did is we said, all right, our utility is going to take an interface that means a little bit more to you, right? Rather than saying, you know, it's min width and max width, we're like, all right, let's make an interface that says, I want to begin at X. I want the style to potentially end at X. And then here's the style. So creating these composite types that actually interface your primitive types allows you to create a utility that's far more utilitarian to use than it is just, you know, slapping some strings on your inside of, like, you know, your style components. All right. So I'm thoroughly confused about my own talk right now. So we're going to actually go into some demos real quick. But first, let's just talk a little bit about our goals, right? We talked a couple of those. So first is our continuity goals. And if you think of like node speak, you can think of your continuity goals as meeting time goals, right? Consistent language across the org. You know, you want simple APIs. You know, when can we customize? When can we can't? Where are our best practices? So those are the goals that you want to like keep in mind when you actually go to use your implementation or interface your implementation goals. And again, those are implementation time goals, right? So what's our API? How are we surfacing errors? What are our escape hatches? What are the APIs into those? How do we make sure that, you know, we're not creating these massive regressions if we do have to change something? So when we take all of those, put them together, we get to this, you know, this nebulous concept of CSS nirvana. So, so Matt, you're up.
I don't think we have any polls left, so this has to go smoothly now. All right, you see the presentation?
Yep.
All right, sweet. Okay, so quick demo, right? And this is going to be a little bit about design systems and funneling your styling through functions as we're purporting to do, and a little bit kind of about how TypeScript helps. So check out this awesome app, right? I basically wrote the same app in both JavaScript and TypeScript, and also wrote that same make color utility function in both JavaScript and TypeScript. And then I built this beautiful thing that's a bunch of chariot icons on a page, and used that make color function some, like, I don't know, 20 times, whatever it is, across this little single page, literally one page app. And importantly, you know, that's a comically small footprint for a function like this, right? 20 usages. In real life, it's going to be more like 200 or maybe even 1,000. And the point is that with the styling stuff, you know, how do we refactor with confidence? And before I move on, I think it's important to remember that the point of this talk is that styling your application is also an architecture problem, right? It is, after all, called a design system. So you should think about it that way. But since we're thinking about it that way, you know, it's kind of like, you know, building an API if you're a backend guy, right? And the problem with building APIs, for anyone who has experience with it, is that it's very hard to get your API totally right the first time. So invariably, a year later, we've been using this API and it's a little bit awkward and there's improvements we want to make and they might require changing the contract. So how do we prevent regressions? So if I flip over to this screen, can you guys see two editors side by side now?
Yep.
Awesome. All right. So here we go. We've got make color, right? On the left, it's written in JavaScript, and on the right, it's written in TypeScript, right? The important point here is that they look almost identical. In fact, the body of these functions, so like lines 44 and onwards and 64 and onwards on the left and right, are literally like character for character identical. So when your JavaScript engineer comes whining to you about how they don't want to adopt TypeScript because they're not going to be able to understand it, here's where you can say, I think that might be BS. They're really not that different at all. On the left, we've got a happy little JS document, and we've been good little boys and girls, and we've documented our function perfectly, right? Or as well as we can. On the right, the same purpose is accomplished just with the type annotations, except I can navigate them, right? And I can inspect this interface and say, oh, when Drew and Matt want me to pass this key called scalable, what do they mean? Oh, they want us to pass a scalable color and optionally a scale position to tell us how they want to scale that color up or down in terms of lightness or darkness. Great. So one important point I want to make here is that like JSDoc can actually do a lot more, and things like, prop types in the React ecosystem are very like fully featured. But since it's just a documentation framework, how often do you see this?
Never, Matt.
I've definitely written it. You have written it, or you've stumbled across it. If you're telling me you've written large JavaScript projects and never done this, I think you might be lying. But if you haven't, then you're doing yeoman's work, and like I want to learn more from you. But the point is, how often do we get param config object, which means what? That I have to use curly braces when I call this function and tells me little to nothing else. So JSDoc is there, but I just want to kind of move on from that. So let's look at this make color API, right? It's a little bit awkward if we go into the color properties. So this object is 3 keys that are all optional. And what our intention is that the user is going to pass one of those 3 keys. So here's black, white, blue, light blue here. And which key they pass is going to determine what type of color we're making, right? So if I pass fixed, I'm using a fixed color. Scalable, I'm using a scalable color that can scale. What's a little bit weird is that like that's a little bit strange, and also like I have to pass this nested object in one case, and it feels a little awkward that I have to do that since it's not that big of an interface. On top of that, from a TypeScript perspective, it's actually kind of has holes in it, right? So if I look at this broken component, I can call make color with an empty object, and that's totally fine. I can call make color with both a custom color and a fixed color, which doesn't really make any sense. That's also totally fine. And that's why on the bottom here, we see these horses that like are just black and white, don't really look like they fit. That's this broken component here that kind of broke our interface. So here we are, we're like writing this app and everything looks good, but we've got some holes. So we want to refactor it. So how do we do that? Let's pretend just for the sake of time that we're already done. So I'm going to switch branches here on both sides. And now we have a make color function that takes a flatter interface. So there's always a key called type, and that's what determines whether we're using fixed, scalable, or custom colors, right? And then if I do pass scalable, the color argument changes and the scale option is optionally there. This is just an example of what's called a discriminated union in TypeScript, and there's actually an even better way to write this interface that I discovered like a month ago, but for the sake of the argument, we're using a discriminated union, and now the language can basically narrow the type when you use control flow around the common property here, right? So if you use an if statement, or in this case, a switch statement around that type property, inside of the fixed block, the type system knows that color is going to be of type fixed color, similarly for scalable and color scalable, and that's great. But the point is, what we've done here is we've refactored our factory function or our utility function and not touched any of the other files in this project. And that's what we get. The left side is the JavaScript project. Everything is totally fine, ship it, right? And again, this is kind of a contrived example, but the point is that like, since CSS is forgiving, the app, I guess we just want a monochrome app now. That's what we were going for. Like, we don't actually know overtly that there's been an error. Now, another important point here is that I'm not being totally fair to JSDoc again. If you have modern IDEs, you do get some warnings, or if you're using lint rules, you can get warnings that kind of say like, hey, the object that you're passing into this function doesn't look right. But what you don't get is this, right? You don't get a command line utility that's actually a full-blown type checker, where it'll tell you, and it's independent of any individual developer's machine, hey, there's 22 errors in the implementation, here's the file that they're in, and here's where they are, right? So that's kind of the point of the TypeScript versus other solutions that are already out there in the ether. So just for the sake of demonstration now, I'm gonna go ahead and start refactoring this thing, right? So now this guy takes a type of, and look at that beautiful IntelliSense color is gonna be dark. Yeah, type, fixed, color, light. And then I'll do scalable. So scalable is not a nested object anymore. Type, scalable, color, secondary, so on and so forth. I'm not gonna bore you guys with the rest, but the point is you make all the squiggly red lines go away. And eventually, once they do, I'm gonna check out a branch again here. Because now you've got a static type checker, you run the type checker again, and everything hopefully looks good. And now the app looks good, right? The app's not broken anymore. On the left, we haven't made any changes yet. And the last thing I'll say here is that, you know, as you go through this refactoring exercise, specifically with CSS on the left, what happens is like, okay, you know, let's make the same changes to this filled component on the JavaScript side. You get rid of the squigglies, and but importantly, you know, things fail in weird ways. So like our JSDoc just knows that this is a string, not that it's a particular enum. And now things look right, but like people might miss that the horse on the left here like isn't quite the right color blue, or something's kind of weird. Or even worse, you know, we have a type error that actually causes the app to crash. Right? So my point there is that, like, you know, the alternatives before were not only like, it's not only that things fail silently, the problem is things fail inconsistently. And making things fail a little bit more consistently is kind of like one of the goals of the approach that we're advocating. Anyway, so that's about it. I'm gonna go back to the presentation here. And then this is another kind of don't take it from us slide. So this is a tweet that literally, I think this guy tweeted this last week, and I was like, oh, perfect, I'm gonna use this in my talk. So Gary Bernhardt's like a relatively Twitter famous JavaScript guy, and someone commented when he wrote a blog post about refactoring something to TypeScript, like, I can just do that with prop types, or I can just do that with JSDoc, which I think is a common argument. And he's got a really good write-up on why that's not necessarily the case. So this is in the slides. I encourage anybody to read it. With that, I think we will move on. Yeah, I'm gonna pass it back to Drew. Here you go, Drew.
Thank you. So, I mean, just like Matt said, think about how powerful just filtering everything through that one interface is. I mean, let's say that, like we talked about before, there's some sort of organizational shift where they tell you to completely redo your colors, right? How many times does that happen? Or like you want to scale your themes a little bit better. Filtering everything through one specific function that interfaces like your very low level primitives is a far safer way, and it's a far more scalable way to accomplish some of those unknown tasks that you inevitably are going to be thrown at you.
The other point is that you can use like a make color function like that when you have those escape hatches, like, hey, tell me all the places where I'm using the escape hatch. Tell me all the places where I've needed to break out of the design, because that's an important thing to know when you go through a refactor like that.
Exactly. And utility-based library allows you to code custom escape hatches, right? It's not just like one standard catch-all thing. If there's a specific escape hatch that you want to make, put that on your interface, make that available, and then refactor it as you need to. So I'm going to continue on just a little bit more talking about some of the other goals that we have. I talked about consistent language, so I'm not going to harp on it too much, but you can see on the left-hand side and the right-hand side, our colors are primary and secondary. And then on the right-hand side, you can see our design primitives are primary and secondary, right? it's kind of like a very kind of dumb, contrived example, but it's super important once it comes down to it, because if you have designers coming at you and saying, hey, I want this to be the primary color, just use the primary color. How many times have you gone to a design, double clicked on the hex value, and then pasted it into your code? This is far more scalable to say, all right, all I can do is just use my utility and tell it's going to be a primary color. So establishing that consistent language through interfacing your design primitives is a far more scalable way than just copying and pasting a hex value. And then the same thing goes with terminology too. So let's say, and this kind of goes to your barrier of entry goal almost, because padding and margin are kind of like nebulous things. If you don't really understand the box model and you haven't worked with a lot of design in the past, it's really kind of tough to understand when you should use what. Like all you really know is that you need some spacing, right? But if you have if a designer has a specific intent on how something should be positioned, as well as how much space should be in between that, central object in the box, using verbiage like inset and outset are far more clear. And then you can actually use that verbiage in your utility. So if you need to make something with an inset of, let's say, 20 pixels, tying that directly to your utilities and then interfacing those properties that you have, specifically your size properties. The inset and outset property types are composed of the size primitive. But when you make these utilities, anyone can do it now, right? So I need to make something that has an inset of 40, use the make inset utility, and then you have a much more type safe system, not just in the implementation phase, but for when people use it, right? You're going to help reduce their error. So with that, I'm actually going to jump over to a quick example that kind of illustrates a little bit this. So I'm going to move this out of the way. So here's our slide deck on the right-hand side. This is Code Sandbox for people who aren't familiar with it. But I'm going to talk a little bit about just using some of the utilities. So Matt already introduced make color, so we're just going to use that right out of the gate. But hold on, before I do that, the requirements are give the box a secondary background color. So here's the box. We're going to give it a make color. We're going to give it that horrible interface that I wrote. Color.
It was good. I liked it.
it
worked. Yeah.
And then boom, secondary.
Version 0.
So you can shoot it with someone while still being type safe about your design system, right? So the next thing that we want to do, we want to make the box container have a size of medium and a size of large. So, it's worthy to note that we're just using inline style keys here, or style props. So we're not really doing anything with style components just yet. So how we go about doing this, right? So we'll go to padding, we'll do make size, and then we can give it a size of medium. Hope I got that right.
You need a colon, or no, you're using it.
All right, and then margin, make size.
Oh, you need to import make size.
That's
That's
it.
what it's okay.
Thank you, Matt. And then I think it was extra large, I believe. All right, boom.
Bingo.
So, there we have it, right? So your editor is really going to tell you where you're screwing up, and it helped me, right? I knew I wanted to make the size a certain way, but my editor told me, hey, you're not using the right interface, or you actually didn't import it. So moving on to another quick example to show you a little bit more of our property utilities. I'm just going to comment this code out here, and we're going to use styled components, much like we actually used in our solution and solutions we've used so far here. Is that we're going to simplify the code for the box container, and this is what we had in our last example, where you have a background of padding and a margin of using make size. But how can we make this a little bit simpler, right, and reduce our barrier to entry? So we'll remove the padding real quick, and we'll use a property utility called make inset. And then here I'll give it a vertical of medium, and then I'll give it a horizontal of medium. Right? So this roughly mimics the interface that you're going to see in any sort of CSS, but it's as simple as using utility that is, by its very nature, documented using the using Typescript. Hold on. So don't want to do that. Same thing goes for the padding and margin down here. Just for the sake of time, I'm not going to go too far into this, but you can see how using these utilities is a really valuable thing. All right, so we talked a little bit before about our continuity. Can you guys still see the presentation now?
Yeah, now I'm back to the presentation. You're good.
All right. So
Yeah.
as far as our continuity goes, we talked about documentation and enforcing best practices. How many times has your documentation got so out of sync that, you know, you need to go back to your markdown document? I mean, Typescript and VS Code and any other editor that you use, using JSDoc above your interfaces that are already defined by their very nature is another very, you know, nice way of making sure that the documentation is always up to date. You're co-locating your documentation with your code as well as the specific interfaces that go into that. And it's pretty kind of an all-encompassing solution. And then we already talked about this, so I'm actually going to skip it real quick. So all things considered, this is a paradigm, right? This isn't just a library. This isn't something that you can just npm install. We are an npm, but don't use it. Everything's
I guess importantly, so like Drew and I are planning on kind of fleshing out this library, and we're using it for ourselves, but it's out there on npm and it's unstable as a psychotic chimp. So don't use it. The point is more the approach, right? Like, I think one thing that's important just historically, like before maybe a year ago, like I was very averse to using a component, to not using a component library like Bootstrap or Material UI. And Drew kind of said, no, like, it isn't that hard. You can do it. And having worked with you, Drew, for however many months it was, I realized that, like, yes, you can do that. You know what I mean? And it's actually not that hard. And implementing it from the ground up helps you build something the way that you want it for your organization, for your developers to consume.
Yeah. There's no black boxes. All of your internals are documented. You can dive through it, and it's a far more rational thing to do if you don't want to introduce a lot of complexity, right? You can use you can use the Ferrari going to school. Like, yeah, you'll still get to school, but did you really need a V8 to go like 4 blocks?
Yeah, and its parts are really expensive, right?
Exactly.
Yeah.
So I just want to talk a little bit about what we have in the future for this, right? So we want to publish a couple articles on this, Medium maybe, but you can definitely go to the Chariot blog and you'll see a lot of these ideas starting to be formalized a little bit more. We do want to plan to code this out a little bit more, and obviously it's open source, so we'd love anybody's help on it. But again, this is ready to go as far as the paradigm goes. You can easily create union types, build those types up, and make your own interfaces for your own utilities. And you can use those in a way where it doesn't have to be fully encompassing, right? So if you just want to start, do like the diet Typesafe design systems, you can create your make color function and use that everywhere where everything takes a color prop. So
yeah, and a lot of these ideas aren't necessarily new. It's just like how to approach this the best way, given the architectures, the solutions that we have at our, that we have in 2020, right?
And then one thing that we are going to do is that the primitive concept is something that you can use now, but the utilities are something that are a little bit more baked out. So when we're actually going to start to build these utilities where we have same defaults that try to address a lot of the harder things of a design system. So making sure that your line height as well as different icons scale at the proper size, how to use rems, ems, pixels, all of that will try to be baked into those utilities to kind of make something that's as scalable as possible right out of the box. So definitely keep your eye out for some more stuff like that. And with that, that's it. We're done.
Yeah. Cool.
Awesome. Oh, wow, you guys got done just in the nick of time. If you guys have any questions, please shoot them over to room A.